Let's take a look at dividing monomials today. First, let's talk about quotients of powers, which, quotient is the answer to a division problem. So this is just dividing powers. So to divide two powers with the same base, all we're going to have to do is subtract their exponents. Let's take a look at why this works. So we start out with a simple problem here. It just says x to the fifth power divided by x to the second power. If we expand that and take a look at it, this is what that problem is saying. I know that I can do some canceling out or actually dividing here, but I can divide this x and that x together, and I end up with a quotient of 1. Multiplying by 1 does not change the value of this. I can also cancel that out, and I'm left with 3 x's on top and a 1 on bottom. As we know, any number with a 1 as the denominator is that whole number, that number on top. So what's left on top is 3 x's. So let's look at why this rule actually works. If we take x to the fifth power minus x to the second power, what we're actually doing is that minus 2 is where we're canceling out. We're able to cancel out 2 of those x's. And what we're left with is x to the third power. So that's just a simple explanation as to why it works. Okay, let's go ahead and take a look at an example here and work our way through this. So it has a few more steps, but let's look at this, and we've got g to the third power h to the fifth divided by g h to the second power. Well, as we know from multiplying powers, first thing we need to do is to group our constants and our variables with the same base, or powers with the same base. We don't have any constants in this, so it's just a matter of grouping the powers with the same base. So I've grouped g to the third divided by g, and over here we've got h to the fifth power divided by h to the second power. We're going to apply our rule that we talked about, that is just simply to subtract their exponents. So when we do that, we've got g to the 3 minus 1 power, and we have h to the 5 minus 2 power. When we simplify that, or we just go ahead and do the subtraction, we're going to end up with g to the second power, h to the third power. So it's a matter of grouping first. If we have constants, go ahead and group those, and then group the powers that have the same base. Go ahead and apply our quotient of powers rule, and then simplify. I've got a couple of examples I want to work through with you here. So let's see what we can do. First things first, let's go ahead and you can write this down in your notebook and we can work it together. So if we group, we're going to have x to the third power divided by x to the second power. That's our first one. And then times y to the fourth power divided by y, and that's y to the first power. So our next step would be to apply our quotient of powers rule, which would say x to the 3 minus 2 power, and it would be y to the 4 minus 1 power. So when we simplify that, we're going to have x to the 3 minus 2, so that's just x to the first power, and it would be y to the 4 minus 1, which would be y to the third power. So the quotient of x to the third power, y to the fourth, divided by x to the second, y is going to be x y to the third power. All right, let's do one more before we move on. On this one, give you a second to write that down there. We've got k to the 7th, m to the 10th, p, divided by k to the 5th, m to the 3rd, p. Again, we're going to group. So as we group, we have k to the 7th power divided by k to the 5th power times m to the 10th power divided by m to the 3rd power times p to the first power divided by p to the first power. So so we've done our grouping. Now let's apply our rule, which was that second step. So on the second one, we have k to the 7 minus 5 power. We have m to the 10 minus 3 power times p to the 1 minus 1 power. Okay? So let's go ahead and work here. So we have, this would be k to the 7 minus 5 would be k to the second power. This would be m to the 10 minus 3, so that would be m to the 7th power. If we think about this, p divided by p is 1. If we multiply this all by 1, it doesn't change it, so our quotient is here. Take a look at that. If you have any questions, let me know. I hope that helps with today's assignment.